Hi, in this session I'd like to talk about the subject which really lies at the heart of just about everything that Structure 101 is and does, namely hierarchy. And why we need it, what Structure 101 gives us for nothing, and how we can manipulate those default views in Structure 101 such that the displayed models in Structure 101 match our mental view of how the code is actually structured. So I'd like to start off in a slightly odd place here. I'm in the slice perspective. I've selected the level of outer class, and within that the main cluster. And what this means in practice is that over here I see a dependency graph showing me all the interactions between pretty much all the classes in the codebase. We're looking at the codebase for Structure 101 itself, by the way. It's not a particularly big codebase, 1300 odd outer classes. Now in a dependency matrix, in fact let's maximize this to get a slightly better view. This blue area here shows me how much of the matrix is currently visible on the screen. I can drag and drop it around to move. Each dot represents some interaction, one class using another class. Now as long as I have this view, it's kind of hard to make sense of. If I increase the cell size, at some point I can start reading the class names, but of course this blue area here shrinks, so now I'm seeing a tiny fraction of the overall matrix. As I go down in zoom level, I get into this bit where I can see dots, no longer enough space on the screen to show actual names or numbers, but at least I can see more of it. So, is this view useful? Well, no. In this particular case, it's not at all useful. There's a mass of information here telling me all kinds of low-level detail about classes interacting with other classes. But can I make sense of it and rationalize about how the code base is structured by looking at this? Well, the answer is no, not really. I need to work at higher levels of abstraction if I want to achieve that. And the key to that really is how we take all these low-level dependencies, which kind of physically, explicitly exist in the code, and roll them up through a compositional hierarchy and look at the way they give rise to implicit dependencies between items higher up in that hierarchy. Let's put a bit more flesh on that now by switching to the collaboration perspective and looking at a concrete example. So I've selected the method resolve in the class AppRunner in the package com.headway.lang.any. Let's deselect varstring over here. So in this state, I can see all the other things in the code base that this method uses. And I want to focus in on one of them here to start with. In the interface varstring in com.headway.util, there is a call from resolve to get varname. I see this down at the bottom. So I can say that there's an explicit dependency from this method to this method. We can wind that out a bit maybe, and let's look at all the interactions between AppRunner on this side and varstring over here. And we see there are actually a bunch of elemental dependencies between all of these items. And so we have the method getArgAt returns a varstring. We have those calls from resolve, etc. Actually, I'm just going to tag these now. Right-click, tag selected. We see these little blue balls popping up. And I think the relevance of that will become more apparent later. Now, if these are explicit dependencies at the code level, but we can say that if AppRunner depends on varstring, then actually the package any must also depend on the interface varstring. In fact, it must also depend on the package varstring, because there is stuff in varstring that it depends on. Let's select that now. And note that this number here has now gone up to 13. So when we widen the scope of the dependency we're interested in, we've picked up a few additional dependencies along the way. We find out that actually AppRunner depends on AntStyle varstring. It's a separate class. We note down here these tagged items that we expressed an interest earlier. There's also a few popped in now, 5, which aren't tagged. So we've picked those up along the way. And what we're talking about here is a dependency from one package, one leaf package, to another leaf package. And that's no longer explicit because there is no code directly associated with a leaf package, but it's implicit from the classes contained in the packages on either side. And we can go up further through the hierarchy and say that actually the entire subsystem com headway lang is dependent on the entire subsystem com headway util. And there are 582 elemental dependencies flowing across the way between these two items. And a big part of what Structure 101 does is really working with these roll-ups of the elemental dependencies and showing how the dependencies that arise implicitly between items higher in our hierarchy. Let's put a little more flesh on that by switching to the composition perspective. Now what we're looking at here is the dependency graph for the first level of breakout in the com.headway codebase. And over here I see with this faded blue dot, that's the tagging again, that number 582. So this means there are 582 elemental dependencies between lang and util. But of course we know that already because we just saw that in the collaboration perspective. Now I'm actually looking at this particular dependency graph in the matrix view, the same as the dependency graph of all the outer classes before. But as soon as graphs get a bit more smaller and manageable, I tend to be much happier working in the diagram view, which I select up here. It's generally much more intuitive. And again, over here now I see there's my 582 elemental dependencies. I've got a few of those tagged. In passing, maybe whenever I see these, whenever I have big numbers of elemental dependencies, this flat list becomes less useful. In cases such as those, it's handy to switch on in here the trees as well as the list. And this is like a mini collaboration perspective, I guess. This shows me the set of, for the selected dependency, the subset of stuff in lang is shown here, that is using the subset of stuff in util. And if I wanted to now, I can drill down in here to see exactly what is it in any one place that uses stuff in another place, and eventually I'll get back to my 8 or 10 or 13 dependencies. Where's that going? Back to varstring, I'll get back to my 8 tagged items. Now it follows that if we're going to roll up elemental dependencies through a compositional hierarchy, we're going to get very different results, very different views, depending on how I choose to organize that hierarchy. And I'd like to talk a bit about that now. In fact, let's just switch over. I'm in the package hierarchy at the moment. I'm going to switch to the jar hierarchy. And the jar is more to do with how the code is physically organized, whether that could be jar files, could be classes, directories corresponding to IDE projects. And we'll see that I have my faded blue dot here. There's a dependency from S101 for any to S101 core. So this dependency crosses jar boundaries. If I drill in to see what's actually causing that, I go in, I pick my little class down here, AppRunner, and in no time at all, I'll see that actually the stuff in AppRunner depends on varstring. So this dependency that we were looking at before in one view, or the elemental dependencies roll up and have one effect in the logical package hierarchy, they have a different effect in this case in the jar hierarchy. Now by default throughout the application, Structure 101 has a preferred hierarchy based on the package. But if this doesn't correspond to how you view your code, if you don't have a one-to-one correspondence between the packaging and what you think of, maybe even loosely, as architectural components, then these default views that you're going to get will be of less use. And this is where transformations come in. I'd like to explain a bit about transformations now. And transformations, in effect, are virtual renames of the classes. And by renaming a class, so by, in effect, saying that this class, instead of being called a.b.c, is actually called x.y.z, will have the effect that it pops up in the package hierarchy in the location x.y instead of in the location a.b. And this allows me to manipulate the package hierarchy that Structure 101 infers from the fully qualified names of the classes. So let's just give you a trivial example of that to start with. All of our code everywhere is called com.headway.star. You can see it up here. And all I want to do now is rename com.headway.star to star. it's going to have the effect of making the names shorter throughout the application. So you can see the com.headway has disappeared here. I haven't actually had any effect on the, I guess, the structure, but all of the classes now think they're called something different. If I mouse over down here, where previously that would have said com.headway.lang.java, the class info now just says lang.java. Let's have a more interesting one. Note at the moment that there are 6 items in this view at this level of breakout. And let's do a different transformation. Let's say take every class who starts with the name test and move him to a different package hierarchy, which begins with test. If we OK that now, what we actually have is that we've got a brand new, I guess, design item, high-level item, popped up in our hierarchy, and we can see various interactions now. The test uses stuff in widgets and foundation and util. So we've manipulated the class names, which results in manipulation of the hierarchy. I'm going to comment that one out. I'm now going to do a really silly one and say every class who begins with T, move him to a parallel hierarchy called T. I'm going to say OK there. And this has the effect when it comes back. I have this new item T, and I've now transformed my hierarchy into a bit of a mess. I had a nice orderly structure before, but by doing something kind of randomly breaking the design, if you like, by moving an arbitrary bunch of classes into a subsystem called T, I've ended up with a chaotic picture of interdependencies. And this is really to illustrate that how we organize the hierarchy is key to the views we get in Structure 101, and how in an ideal world these can reflect our design components, show us the interactions between those, and help us to achieve an orderly structure. So that's a bad transformation. I'm going to get rid of that now. There's one more I'd like to go through briefly, which is the jar transformation. So by default, Structure 101 uses the package hierarchy. Now, if you're very into your jars as the primary thing and much less interested in package names, then you may well want to be using this transformation when you look at Java code. So I'm going to execute that now. And what happens here is that I actually see a breakout based on, this is the same hierarchy that I was seeing in the jar hierarchy before, but now it has the effect that this is propagated throughout the whole of Structure 101 and all the perspectives and architecture diagrams and measurement perspective and everything else. So if you are primarily interested in the jar view of the world, then you may well want to work with this transformation. The very final thing I'd like to mention about transformations is that they're cumulative, so I can apply transformations on top of other transformations. So in this case, I've said that show me the jars first and foremost. I note that nearly all of them here begin with S1014. This is where we have our language-specific parts of the code, like the language specifics for Java or for the generic product or for the C++ product. If I now define a second transformation on top here of the previous one and say S1014 star 2 dot star and transform that to lang, let's just do it and see the effect. What I've actually done now is taken all of the group together, all of these other guys under the heading lang, and now I can see the breakout down here. And the real point is that if you have some notion of what your design items are, then it, with any kind of naming scheme, then you should be able to map that to Structure 101 through using Structure 101 transformations, so that the views you are getting conform to that, your view of the world, your notion of how the architecture is constructed. Okay, let's get rid of those transformations. Deactivate all. So once you can achieve this view, what Structure 101 really gives you is the ability to see what's going on. And I guess that the ideal outcome is that you begin to treat these design items as first-class citizens in your code base. Structure 101 makes it visible as to how they're composed and what the interactions are between any component and the other components in the code, with the goal that you have an orderly breakout, an orderly, understandable breakout at each level in the code base. Mind-sized chunks. Now, I'd like to talk about all of that stuff a little bit separately in another demo about the ideal structure of code. I guess just to finish off, let's have a quick look at, which we open Terracotta from the structure101.com repository. We won't save that. And most of the code in Terracotta is in TC. And this is the kind of picture you see on lots of code bases. And this is kind of the opposite. So this is where I think it's fair to say, maybe there's some magic set of transformations which would make sense of this code. But in the absence of the visualization of the inter-component dependencies, then I think it's natural or inevitable that so at least the packages will not be treated as first-class design or first-class citizens in the design, and that almost inevitably leads to this kind of picture where basically the structure of the code base is everything uses everything at the higher levels. And if we want to make sense of this code base now, where we can't really rely on any of these items here because they're all looks like arbitrary subsets. So to make sense of this code base, we'd probably go off to the slice perspective, just minimize that, and pick the outer class layer, and maybe start off with this kind of view of the world and work at this level. Well, it's not quite that bad, but maybe we'll cover that in a separate session. Okay, thanks a lot for your attention.